While we consider stars, we likely imagine little polished things in the evening sky. Basically, this is the impression we get from down here on the planet. Anyway, stars like Betelgeuse are something totally different. In all honesty, one of the most noteworthy stars, Betelgeuse, happens to be much greater than our Sun. For a truly prolonged stretch of time, this star has puzzled scientists. Yet, actually, something additional upsetting has been happening with Betelgeuse, making specialists and other well-informed individuals incredibly concerned. Join us in this analysis as we examine the sensational news about Betelgeuse, its approaching destruction as anticipated by the James Webb Space Telescope, and how this new advancement will impact our universe and our lives here on Earth. As explained by physicist Michio Kaku, Betelgeuse is a boundless wonder, a tremendous star that has enchanted cosmologists for so long. A Greek astronomer named Ptolemy was the first to observe it. This star is huge to the point that it can be seen in the night sky from Earth, especially during winter. If you're into astronomy, you've probably seen or heard about this star. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is old and is, so far, one of the most brilliant stars in the night sky. Anyway, one thing about Betelgeuse's brightness is that it doesn't stay consistent, it fluctuates. This variation is one of the intriguing properties of this star, but it isn't the only one. Let's look at some of Betelgeuse's specific properties. The majority of the stars you see in the night sky are a long way from Earth. The nearest star is 4.2 light-years from Earth. If you don't understand how the term light-year relates to distance, picture it this way: consider moving at the speed of light for a whole year. Light can travel a distance of 186,000 miles per second, therefore, the distance light can cover in a year is equivalent to 1 light-year. Assuming you calculate it, you'll end up with billions of miles. So, when we say the nearest star is 4.2 light-years away, it means it is billions of miles from Earth. Anyway, some stars are even farther away, and Betelgeuse is one of them. Betelgeuse is located approximately 600 light-years from Earth, so if you were to travel to it at the speed of light, it would still take 600 years. We can't move that fast, not even our fastest spacecraft can. Yet this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so bright despite its distance, it's due to its remarkable attributes like size and brightness. Betelgeuse is 700 times larger than our Sun, and its radius is believed to be 1,400 times that of the Sun. When observed using complex telescopes, Betelgeuse appears as a disk in space, while other stars appear as tiny points of light. This visibility is thought to be an effect of the reactions on the outer layers of its atmosphere. In terms of mass, Betelgeuse measures around 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. 1 solar mass equals 2 times 10 to the power of 30 kilogram. Experts can't determine the exact mass of Betelgeuse since there are no planetary bodies orbiting it for comparison, and clearly, we can't measure it directly from here. The fact that this star is many times heavier than our Sun makes it interesting. The brightness of Betelgeuse ranges from magnitude plus 0.0 to plus 1.6. In simpler terms, Betelgeuse is 100,000 times brighter than our Sun. No wonder it was nicknamed a red giant. However, the brightness of Betelgeuse doesn't stay consistent, it varies. This change in brightness is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it becomes brighter, but when it contracts, it dims. This cycle can last from 10 to 100 days or even longer. One remarkable property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is much stronger than at the usual surface. However, the downside is that these strong magnetic spots limit the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has many of these spots compared to our Sun explains why it is cooler than our Sun, despite its size and brightness. The Sun also has dark magnetic spots, but those on Betelgeuse are much larger and more numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is 10 times stronger than that of the Sun. This field is why, when seen through a telescope, the gases on Betelgeuse's surface appear to be in swirls or arcs. Betelgeuse has a surface temperature of around 3,500 Kelvin. This low temperature contributes to the low energy produced by the star and its dim red color. Betelgeuse is a red star, but it wasn't always red, it was yellowish around 10,000 years ago, much like our Sun. Over the years, its color started to shift to orange-red, and then, about 1,000 years ago, it gradually transitioned into the red star we know today. This fact has led researchers to believe that the star is aging. Betelgeuse produces as much as 100,000 times more energy than the Sun. It would have been a fierce competitor to Earth's Sun if it weren't so far away. Additionally, the fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite remarkable. Our Sun is only 8.3 light-minutes from Earth, and that's why it appears so powerful. If Betelgeuse were just a bit closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would burn or displace Earth and the other 4 planets close to it due to its enormous size. Moreover, even if Betelgeuse could match the Sun's energy output, it still emits more radiation. Betelgeuse, otherwise known as Betelgeuse, is a gigantic star located in the Orion constellation, about 600 light-years from Earth. Its colossal size is one of its most striking features. It is approximately 1,400 times larger than our Sun in terms of radius and could easily encompass the orbit of Jupiter if placed at the center of our solar system. This giant size allows Betelgeuse to appear as a visible disk rather than a point of light when seen through powerful telescopes. Unlike most other stars, Betelgeuse isn't the most massive star. Its mass ranges from around 12 to 19 times that of the Sun, depending on various estimates. One of Betelgeuse's most intriguing characteristics is its variability in brightness. Unlike our Sun, which maintains a fairly consistent brightness over time, Betelgeuse undergoes irregular changes in its brightness. These variations are attributed to pulsations within the star, caused by changes in its internal processes. At its brightest, Betelgeuse can shine 100,000 times more brightly than our Sun. However, during dimming episodes, its brightness can drop significantly. These changes have been a subject of intense study among astronomers. Observations over the centuries have documented these changes, providing valuable insights into the star's life cycle. The hydrogen fuel in its center started melding into heavier components. This combination process produces energy and causes the star to extend outward. The star's atmosphere is rich in complex physical peculiarities. It shows dark magnetic spots on its surface,
which are altogether larger than those seen on our Sun. These spots are regions of intense magnetic activity that thwart the flow of hot gases from deeper inside the star to its surface, adding to cooler regions on the star. Betelgeuse has been known and seen by different civilizations for a long time. Old cosmologists from various societies, including the Greeks, Egyptians, and Chinese, recorded its position and noted its brilliance and variety. In ancient Arabic cosmology, Betelgeuse's name, Yad al-Jawz, meaning the hand of Orion, mirrored its prominent place in the constellation. Its visibility and variability have inspired various legends and cultural references throughout history. Recently, Betelgeuse has garnered expanded scientific attention due to its dimming episodes, which began around late 2019 and continued into mid-2021. During these periods, the star's brightness dropped to unprecedented levels, sparking hypotheses among astronomers about its impending fate. The most discussed speculations include the possibility of Betelgeuse going supernova in the near future. Supernovae are cataclysmic events that happen when massive stars exhaust their nuclear fuel and undergo gravitational collapse. If Betelgeuse were to go supernova, it would release an enormous amount of energy and become one of the brightest objects in the night sky, visible even during the day. The expected supernova of Betelgeuse has captured public imagination and scientific interest due to its proximity and visibility. Astronomers continue to monitor the star closely using telescopes and space-based observatories to gather information on its behavior and evolution. Betelgeuse's status as a red supergiant provides significant insights into the later phases of stellar evolution, including the fusion of heavier elements in the star's core and the possible dispersal of these elements into the interstellar medium. Betelgeuse's fluctuations, historical significance, and potential for a supernova make it for centuries. Astronomers have documented changes in Betelgeuse, providing valuable insights into the star's life cycle. The hydrogen fuel in its core has begun melding into heavier elements. This fusion process releases energy, causing the star to expand outward. Betelgeuse's atmosphere is rich in complex physical characteristics, including dark magnetic spots on its surface, which are much larger than those seen on our Sun. These spots are regions of intense magnetic activity that hinder the flow of hot gases from deeper within the star to its surface, contributing to cooler areas on the star. Betelgeuse has been known and observed by various civilizations for thousands of years. Ancient astronomers from cultures such as the Greeks, Egyptians, and Chinese recorded its position and noted its brilliance and color. In ancient Arabic cosmology, Betelgeuse's name, Yad al-Jawz, meaning the hand of Orion, reflected its prominent position in the constellation. Its visibility and variability have inspired numerous legends and cultural references throughout history. Recently, Betelgeuse has drawn increased scientific attention due to its unusual dimming episodes, which began in late 2019 and extended into mid-2021. During these episodes, the star's brightness dropped to unprecedented levels, sparking speculation among astronomers about its possible fate. One of the primary hypotheses is that Betelgeuse may be on the verge of a supernova explosion. Supernovae are catastrophic events that occur when massive stars deplete their nuclear fuel and undergo gravitational collapse. If Betelgeuse were to go supernova, it would unleash a tremendous amount of energy and become one of the brightest objects in the night sky, visible even during the day. The anticipated supernova of Betelgeuse has captured public imagination and scientific interest due to its proximity and visibility. Astronomers continue to monitor Betelgeuse closely using telescopes and space-based observatories to gather data on its behavior and evolution. As a red supergiant, Betelgeuse provides crucial insights into the later stages of stellar evolution, including the fusion of heavier elements in its core and the dispersal of these elements into the interstellar medium. Betelgeuse's fluctuations, historical significance, and potential for a supernova make it a compelling subject for ongoing and future research. Studying Betelgeuse helps astronomers better understand stellar evolution, large-scale phenomena, and the complex processes that shape our universe. Most people perceive stars in the night sky as tiny, twinkling dots of light, but stars like Betelgeuse are far from that. This star, part of the Orion constellation, is one of the largest and most famous stars visible from Earth and holds a truly cosmic story. Betelgeuse, located about 600 light-years from Earth, is a red supergiant star, indicating it is in the later stages of its stellar life cycle. Although its vast size is difficult to grasp, its diameter is estimated to be over 1,000 times that of the Sun. To help the center of our solar system, it would extend beyond Jupiter's orbit, engulfing several planets. Despite its enormous size, Betelgeuse's brightness fluctuates dramatically. It is more than 100,000 times as luminous as the Sun at its peak, yet periodically dims significantly, prompting scientific discussion and public curiosity. This dimming, most noticeably in late 2019, led to widespread interest in what could happen next. Is it on the brink of a supernova? Astronomers and astrophysicists have been captivated by Betelgeuse's behavior, especially the dramatic dimming observed over several months in 2019 and 2020, during which Betelgeuse became one of the dimmest stars in Orion, an unprecedented event. Although this event raised excitement about the possibility of a supernova, a massive explosion that happens when a star runs out of fuel, the dimming's cause was later found to be less straightforward. Subsequent studies indicate that the dimming was likely due to a dust cloud around the star. Betelgeuse continually expels material into space, and at times, this material forms dust clouds. When one of these clouds obscured our view, it caused Betelgeuse to appear significantly dimmer than expected. Although this dust cloud temporarily reduced its brightness, to fully understand Betelgeuse's significance, we must consider its life cycle. Like all stars, Betelgeuse originated from a massive molecular cloud of gas and dust. For much of its life, it fused hydrogen into helium, similar to our Sun. However, this fusion process generates more energy, causing the star to expand to its current size as a red supergiant. Stars like Betelgeuse ultimately conclude their lives in a supernova. Once Betelgeuse can no longer sustain fusion in its core, gravity will force it to collapse inward, sparking an enormous explosion that will outshine much of the universe for a brief period. If Betelgeuse does go supernova, it would be visible from Earth during the day, despite its 600 light-year distance. This remarkable event would release elements like iron, calcium, and oxygen into space, enriching the interstellar medium and potentially helping to form new stars and planets. Supernovae and their aftermath are crucial for creating elements that compose planets, a dense core remnant. There is no cause for alarm. This explosion is expected within the next 100,000 years, so it is unlikely that we will witness it. Even if Betelgeuse were to explode tomorrow, its immense distance from Earth means it poses no danger to our planet.